All right, with our active pneumatic downforce, the thing that we are monitoring is margin, and that is the additional amount of downforce applied above and beyond what is required for seed penetration to achieve the proper planting depth. The factors that come into play on margin are the weight of the row unit, the downforce that's being applied to the row unit, and the upforce or the resistance pushing up on the row unit from the soil. Things that downforce impacts. It's going to affect the trench sidewall, ride quality, seed singulation, your seed spacing or your CV value in your display, ground contact, emergence, and most importantly, it's going to affect your yield, 5 to 9%. Impacts to yield because of your downforce. You're going to have a 2 to 4 bushel impact on because of correct population, a 2 to 4 bushel per acre effect from uniform spacing. The biggest impact you're going to see is getting uniform emergence at 10 to 18 bushels per acre and achieving the proper planting window at 4 to 10 bushels per acre. And this is based on a study done at the University of Minnesota on a 200 bushel per acre plot. It's important to remember while setting downforce to set enough but not set too much. The amount of downforce needed will vary from field to field depending on your field conditions, varying on your amount of tillage, whether you're no-till, crops you're going through. Running too little downforce is going to cause the row unit to hop and you're going to get poor ride quality. The openers are going to rise up out of the ground, getting poor ground contact. You're going to get improper firming of the seed furrow, improper seed depth, and varying seed depth across the rows in the entire field. Running too much downforce will cause excessive wear on the openers and gauge wheel bearings, shear rivets on the true V hubs, and more importantly can cause compaction of the seed trench sidewalls, resulting in poor root growth. In this scenario, you're going to see what correct downforce settings looks like. On the left-hand picture here, you're going to see, and this is with the closing wheels removed so you can see what it looks like, but you're going to have a defined seed trench. You're not going to have any loose soil with the seed. The seed depth is going to be consistent on all rows on the planter across the entire pass of the field because the openers are not riding up out of the ground. The sidewalls of the trench are not caving in, allowing loose soil in with the seed, causing the inconsistent depth. And the sidewalls aren't going to be compacted, allowing optimal root growth into the soil. And then with the right amount of moisture and sunlight, you should achieve maximum emergence and maximum yields. With too little downforce, you're going to have inconsistent depth. You're going to have trench sidewalls are going to be caving in, loose soil with the seed, and you're going to get inconsistent depth, and you're going to have poor seed to soil contact. The photo on the left, you can see with the sidewalls caving in and you don't see a defined trench. And then on the right-hand picture there, you'll see the effects of too little downforce where you're getting uneven emergence on your plants. Running too much downforce, you're going to see in this, like in this photo, you're going to have the gauge wheels putting too much pressure on the soil, causing that peeling effect, and the trench sidewalls will be very compacted. And because of that, you're going to have poor root growth outside of that trench. The picture on the right is a good one to go off of. After you're going back and checking your root growth of your crop, you have a really defined seed trench still there even after the amount of time that's went by on that, and then it's going to have poor root growth outside of that. I've got a quick video here that gets a little bit more in depth to understanding margin with your active systems.
This video is designed to help you better understand row unit downforce margin. Understanding margin is key to optimizing your planter for both active and non-active downforce systems. Downforce margin is the amount of additional downforce applied to a row unit above and beyond what is required for penetration and to achieve full planting depth. The John Deere SeedStar XP monitoring system measures downforce margin with load sensors located in the row unit gauge wheel depth control handle. Setting downforce margin properly will ensure that the openers achieve full planting depth and that the gauge wheels provide enough firming of the seed furrow to prevent the walls from collapsing. Proper downforce margin also prevents excessive row unit bounce, which may cause uneven seed spacing. To properly set the downforce margin for your conditions, follow these steps. Plant a small test strip. Note the high, low, and average margin value in the lower right-hand corner of the downforce run page. Stop the planter in the lowered position. Exit the cab and check to see what the seed furrow looks like at this setting. Do the walls of the seed furrow look firm but not compacted? Is the seed planted at a consistent depth? Are the gauge wheels firming the furrow correctly? In this example, the correct downforce margin is being shown for the field conditions. Notice how the seed is planted at a consistent depth. The walls of the seed furrow are firm and not crumbling, and the gauge wheels are firming the sides of the furrow correctly. If a field check confirms that downforce is correct for your field conditions, you have determined the proper target margin value for this field. The average and target margin should now be nearly equal. The function of the gauge wheels is to provide depth control and firm the soil against the openers to create a defined seed furrow. There are many signs when downforce margin is not properly set. Too little downforce margin will prevent the opener from planting at a consistent depth because the gauge wheel may intermittently come off the ground. Too little margin may also cause the seed furrow to collapse in front of the seed drop, resulting from too little pressure on the gauge wheels. In this example, too little downforce margin is being shown for the field conditions. Notice how the sides of the seed furrow are crumbling into the seed trench and the gauge wheel tracks are uneven. Low margin may also cause overall row unit ride quality to be poor. The gauge wheels should just barely be able to be turned when in the planting position. If the gauge wheels spin too easily, downforce margin should be increased. If the gauge wheels cannot be turned by hand, this is a sign the downforce margin may be too high for field conditions. If there is too much downforce margin, the side walls of the seed furrow may be compacted. The sides of the seed trench may appear slick or smeared. In this example, too much downforce margin has been set for the field conditions. Notice how the sides of the seed trench are compacted. The gauge wheels also may leave deep tracks or ridges in the soil from too much pressure. If your field check confirms that the downforce margin target is incorrect for your field conditions, you will need to either increase or decrease the row unit downforce setting to compensate and perform the field check again. Watch Using Set Point Control or the Using Active Pneumatic Downforce videos for more information on operating your system.
The three factors at work when a row unit is running across the field are the weight of the row unit, and that's going to include your seed pushing down. This weight's going to go down as the seed hopper is empty, and it should stay consistent with a CCS machine. The amount of downforce that's being applied to the row unit, depending on what system you have or what the operator has it set at, and the resistance of the soil pushing up on the row unit, also depending on the amount of residue, tillage, and ground speed is going to have an effect on that too. So, to calculate margin, you need to add the downforce being applied to the row unit and then subtract the resistance. So we got a quick problem here for you to figure out. On this example, we have 200 pounds of downforce that's being applied to the row unit. The weight of the row unit is 100 pounds, and the upforce pushing up on the row unit is 150 pounds. What would our margin be? $150? Yep. 150 is our margin. The next thing we're going to go through are the different types of downforce that we offer and where we've gone to where we've gotten today. The first we have is the heavy-duty mechanical springs. They have manual adjustment levers at each row and must be manually set. The 4 different settings that they come in are 0 pounds, 125 pounds, 250 pounds, and 400 pounds. And that's a list of the models that the heavy-duty mechanical springs were offered in. Next we move to the most common downforce systems used on the various pneumatic systems, and that's where we have our air springs on each row. They have an infinite amount of settings between 0 and 400 pounds. It's available on all the models, and they come in the standard or integrated with a display. The first of those is the standard pneumatic downforce system that is separate from the planar electrical and hydraulic circuits. This would be your small compressor that you have mounted in the cab of the tractor, and you're going to have a mechanical gauge on that compressor that you're going to monitor, and you're going to have a switch that you flip on and off to pump up the pressure on your downforce and dump valve to relieve pressure on the downforce system. The next we have is the integrated pneumatic downforce system, and this is going to be most likely a compressor that's mounted on the hitch of the planter, and you're going to have a control on the display where you're going to have a pressure sensor that's going to give you a reading in your display what your downforce is at, and you're going to manually have to raise and lower your downforce in the system. When you do this, the controller is going to activate a valve at the compressor to release or add air, and it's just going to monitor your pressure on the display for you. Then we have set point pneumatic downforce systems, and it's going to be the same as the integrated system, but you're going to have a control on the display, and you're going to set a target pressure, and the system is going to maintain that air pressure in it for you to keep at that target that you have set. On some of these systems, they have gauge wheel sensors mounted in the select rows, so then you can monitor the row unit ride quality, the ground contact, and margin, but this is just something that you monitor in the display as you're going. Like I said, you're going to enter your target downforce in the display, and it's still going to be a controller activating the valve to relieve and add air to the system. Then we get our active pneumatic downforce system, or our SeedStar XP, And this is going to also be the same as the integrated system. It's going to have the gauge wheel sensors mounted on the selected rows. It's going to monitor the row unit ride quality, ground contact, and you're going to have margin bar graphs. The biggest difference on this is from the other systems. The other systems, you're going to be monitoring the pneumatic downforce pressure on it. This, you're going to be entering a target margin value, and that's what you're going to be monitoring. Another big difference with the active system is you're going to have the big hydraulic compressor like we have on the back of this planner here, so it can make those quick changes to the system as you're going through. Then we get past that, what we have on this planner here is our individual row unit hydraulic downforce system. It's going to have the downforce reading on the display and everything like our active system, but it's going to have gauge wheel sensors in every row, and it's going to make adjustments to individual rows up to 5 times a second. It's going to monitor your ride quality, ground contact, margin, and the applied force on your bar graph, and it's going to make changes to field condition changes. Also measures in margin like your active pneumatic does. And the controller is going to activate a solenoid at each individual row to control the oil pressure to each actuator and accumulator on this system. With the IRHD system, you're also going to get on-screen diagnostics for diagnosing problems. This system isn't recommended for 6R tractors or IT4 or 7R tractors because of the hydraulic requirements needed to run the system. And then we have this was showing you what your run pages would be for the individual row unit hydraulic downforce system, whether you have on the left with your Seedstar 3 running on a 2630 or Seedstar 4 running on your Gen 4 display. And then finally, the thing I just wanted to hammer in your head, I guess, is if you have the active pneumatic downforce system and you think you're running in it, it's always good to check. If you have the active system, you also can run in set point mode. The biggest thing to keep in mind is if you're running in the set point mode, you're going to have this fork icon, and that's going to be monitoring and maintaining pressure in the system, and it's not going to react to the field changes. If you're running in active mode, you're going to be measuring margin on the system, and it's going to have the pieces of the pie similar to like what you'd have with the auto track pie chart, showing that it's meeting the conditions needed for it to become active. So that being said, we'll go over to Lance and poke some buttons.
Alright, well, I'm first going to start out here with our row unit and talk about just a few components that we have with this hydraulic system. And so right here we have our hydraulic actuator, and like I said, John listed them all off, so I'm just going to point to them. This hydraulic actuator, we have an accumulator here that helps absorb that shock. And then we have our pressure sensor right here, as well as a downforce, the valve coil here. So that valve coil, that's what's doing all the changes at that 5 times a second. And that's all controlled. There's a row unit controller inside here, sits like that. And that's doing all our calculations, lightning speed. So that's what's controlling that. The question sometimes gets brought up about hydraulic downforce. They wonder why you have to go to an electric drive planer to get the hydraulic downforce, and that's because of this row unit controller, or RUD as we call it. So the other kind of piece with the downforce is our downforce sensor, and that's in our depth control there. And it mounts there in that mustache on that. So every row has those components versus like our pneumatic system. We only had 3 or 5 downforce sensors across the whole planer. This those are kind of the components there. So what's probably something that you want to do when you hook that tractor up with the downforce before you go to the field? What's something you want to do with the downforce system? That's right, air purge. So we've got this hose, we want to make sure we never lose that. But we do have to bleed the air out of the system, otherwise you can have erratic performance. It gets to be a little jittery at that point, but there's a port that looks like this. Just a jumper hose connects one to the other. And really what that's doing is that's taking our oil and dumping that to the turn line, which goes back to the tractor, and that's how it's getting air out of the system. And so that's something that we want to do. And obviously after we're done, we want to make sure we remove that hose. And so I always like to start off on the screen here and showing how we get to that. So I'm on the Gen 4 here on the planner details page, and I'm going to go to tools. Now I'm going to go to planner diagnostics and calibrations. From that I'll drop down to procedures. Now I can see there's several here in this list, but this air purge is what I want. So a couple things that we need to have. Also, we need this hose hooked up on like a 16 row, 75 or 24 row. There should be ports like this on either end. If we have like a stack full planner, there's actually going to be in sections of how that stacks. And so at that point, we would need to do each section. And so the other thing that we need is for accurate results, we need the oil temp 120 degrees or warmer. And so to do that, a quick way to kind of heat that oil up is whether we're running some vacuums, run that CCS fan if you have a CCS machine, and then deadhead and SCV that you're not using. That kind of builds pressure in the system, heats that oil up a little faster than it would if you're just kind of sitting there. So especially on a day like today, it'd be really hard to get to 120 degrees. And so this is something that we want to do, you know, more than just the day that we go plan. We want to do this a few days before, that way that's all done. You know, a lot of times you don't necessarily have to do it just to pull the planer into the shop if you have to want to look over some things, but definitely do it the last time that you hook that tractor up to this planer before you actually go to the field. So to do this at beginning procedure, there's a couple prereqs that need to be met. You can see those on the screen, and then hit next. And so it's going to allow me to hit the start row and end row. So like on this one, I'm just going to do all rows at once. And then at that point, I would hit next and it would start the procedure. So, any questions on air purge? The other one that in this list that I like to do is the valve test, and that's the one here on the bottom. And that's testing our valve, like I pointed out before. Really, that's what's making our finite adjustments 5 times a second. And so running into the valve test, once again, good to have oil above 120 degrees. We do need pressure at this point. Once again, remove this hose once you've done the air purge. The next page, it would allow us to once again select the rows. So I just start, like I said, row 1 through 16, and it's going to work its way from the outside in and testing those valves, kind of turning on and off at different lengths, I guess you might say. That's what it's doing, is testing that valve. If for some reason, I've seen before where a valve will fail in that test, at that point what I'm going to do, let's say for instance row 12 failed here, at that point I'm going to kind of isolate that row and do the test over, but I'm going to start at row 11 and end on row 13, so I kind of have one on each side of it, and then I'm going to run through that test again. And a lot of times at that point it'll go through. Like I said, that's what I've experienced in the past, can happen. If that still fails at that point, and since it kind of fails 2 times, then we probably have a bad valve and need to replace it. So if we do have a bad valve, we can open that up, replace it, and once again, need air purge. So anytime you introduce air into that system, we need to do an air purge on it. Like I said, that way we don't get some jolty performance. When we engage it here in just a bit, we kind of hear some pulsing. We haven't been able to to purge this one, just being the setup that we have. But that's kind of gives an example of what it might do. So, any questions on purging or valve tests? All right, we'll jump in. Go ahead and look the planer up. All right, so coming here on the kind of the main run page, I'm going to go to the gauge wheels. All right, so this is kind of our downforce page. We have a couple different bar graphs. I'm going to go to our downforce margin. And I first want to start talking about our pie graph. And so the top left here, the pie that's filled in that darker gray, that's saying, hey, we have hydraulic system, we got sensors, they're working. At that point, it's ready to be ready to see the other conditions that need to be met. This top right third, that's our speed portion. All right, so we actually need two speed sources. One, we need a tractor speed, whether that's coming from the radar or GPS. And the other one we need is the planar motion wheel sensor, which, John, we have a radar simulator on both of these. And so, and that wheel motion sensors on the main frame is usually found on the furthest left wheel. That's where that's found at, from the back of the plane. So once we have both of those, we can see that did fill in a solid gray. So we know that condition is met. This can be used as a good diagnostic tool. So for some reason, if you're not getting that second piece of the pie, your tractor's moving, at that point, well, we need to see, okay, am I getting tractor speed, or is my wheel motion sensor working? Those are a couple things that we can really start to think about. This bottom one, I feel like I remember the easiest, but it's the planer lower. So when we lower the planer, that is going to fill in. And we did have an issue with a row unit height switch not getting power, and so we weren't able to fill in that that bottom piece of the pie. So once again, that's kind of how we can use it as a diagnostic tool, even before we go to the field at that point. So once we get all three, go ahead. Once we get all three, this should go ahead and engage. And it'll say engage. This is our active downforce, like we talked about earlier. We want to keep that on. That's how the system was designed to run. It can run in that set point, but at that point there's some pretty erratic performance that comes from it. And so we're going to have that engaged. So just while I'm on this page here, this is how I can adjust my target margin. So once again, we're working in margin, the difference of what's being put down with your row unit as well as hydraulics versus what's being pushed up, the resistance from the soil. And as we know, with speed, this requirement of this number will increase. So just keep that in the back of your mind. This is our margin, and then this is our downforce. So this number here, that's what that planer is putting down itself. So if I wanted to adjust this, I could come down and bump that down, and then come back here. All right, so this is kind of the main run page. This is the run page I really like to run on a lot. And then as we can see here, what I want to see, this is my downforce margin. Anything above means I'm above my margin, and likewise for below. So I want to see a lot in the black. If I see anything up here, I can go back to my main page. But if I see anything that's green or red needs to be looked at. And so at that point I touch that. I see there might be something that's going on with row 1 that we do need to look at. Say for instance, I want to come and look at row 16. That seems to be the highest. I can actually give a touch that row 16, and then touch it again. And this is going to really dive down deeper into this certain row. So everything that's going through here is running through our row unit controller on this row. And so I'm just going to talk about this stuff here. This is our downforce margin. We have our target and our actual on this row, as well as the downforce, ground contact, right quality. Example that I've had is on our right quality map with Connect Mobile. I was with the customer, and there was a couple rows that were really the right quality was in the red, and so we were trying to figure out why. You know, what's going on? Do we have some bad downforce sensors? You know, is the system not working? What's going on? And it seemed pretty consistent, and so really went to this page here and was able to narrow this down. And I looked, and I saw that my downforce, what that planner was putting down, was actually about that 470 pound mark, which is about the max that this hydraulic system will put down. Our old pneumatic systems, like over here, kind of maxed around that 400. So you kind of got to be careful of that. We were running in this compacted ground, ended up being some tracks from a previous pass that caused some compaction that those rows were finding. But once again, that's how the advantage of the hydraulic system, those two rows, we weren't quite able to reach that target margin, but we still were able to put some more downforce just on those two rows. So we'll go back to this map as well, or this page. Like Connect Mobile, like I said, if you don't run it with electric drive planner, I highly encourage you to just a visualization, especially, you know, a lot of times we have a lot of things to look at that point, so being able to go back and see on a map and narrow that down to see, try to track what's going on at that point. The other things here that we can look at, in this right here, this is my downforce. So in that example, there was two rows here in the middle that were putting a lot of down, were pretty much maxed out. That's just, like I said, that's what's showing the downforce every row. Going back here, this is my ground contact. I love this layer to look at when I'm trying to set my downforce. Once again, nothing beats going out, getting out of the cab, and looking at our C-trench. Make sure we roll that gauge wheel at that point. But I like my ground contact to be in that high 90, that mid 90 to high 90 range. It's an algorithm that's really kind of what it says, you know, what percent of the time are we at good contact, achieving our margin, as well as achieving that seed depth that we're going for. And so it shows an average as well as the low row there. You know, we would think, okay, I should shoot for 100%. And, you know, that's not bad thinking at all. One thing I would caution you on, especially if you're running your average at 100% a lot of the time, chances are you actually may have too much downforce. So as we know, that hydraulic, it'll stick it in the ground. I've seen, especially on some really hard soils, probably should have been inline ripped, but we started to break some things. So it got it to the depth though. So if we're at 100% all of the time, that means that row unit is really not moving at all. That's why I said I like to be in that mid 90 to high 90 range for my ground contact. Any questions on some of this stuff here? There are modules that we can put on our different home pages as far as to just make quick adjustments on our downforce margin if we want to, but this is a page I like to see. I like to have my population as well as everything with my downforce and ground contact, and then on another extended monitor, I might run like auto track and machine settings, SCVs, stuff like that. So that's what I like to see.
So if you're running in pretty consistent conditions, what would the optimum margin that you would like to see be?
The optimum margin, obviously it's going to depend on a lot of things. A good starting point that I like to start out with is probably around that 75 to 100 mark. Like I said, that'd be, you know, fairly decent mellow conditions. Obviously, you know, sometimes our no-till soils can be a little tough, so you might have to bump that up some. But once again, that's going to be accelerated a lot with speed. So you start to go at 6, 7, 8, 9, 10 mile an hour, we're going to definitely have to increase that, because, you know, speed might increase linearly, but your requirement for the downforce is actually going to increase exponentially. So just kind of remember that when you are trying to set downforce. But like I said, good starting points kind of be around that 75 to 100. And then once again, you don't have to go very long. Get out and start to really investigate that seed trench as well as your gauge wheels to see where you're at. Good question. I can go to the tools here and go to my planner diagnostics as well as calibrations. So if we feel like our downforce sensors maybe aren't quite working right, we can go to this gauge wheel downforce calibration, and what that's going to do is that's going to just set our 0. So obviously we want the planner up, and then we can just set our 0. That way there's no load, you know, previous. That way it's working properly. The diagnostics, several different diagnostics for electric drive planners. You know, we have gauge wheel downforce. I can look at all of our loads here, and I can see that whether I have voltage to them and whether they're giving me some voltage back and what the loads are on it as well. So that's one page you might look at. While I always go there just to show that these enable check boxes. So on our old pneumatic systems, we were used to have a sensor that goes bad. I can just disable it because it's taking an average. On these hydraulic systems, I discourage that because every row is different. It no longer is taking an average. And so at that point, that row, you know, if you disable it, it's just kind of there. It's just hanging out, not really knowing what to do, you know, so your performance is affected at that point. Once again, that diagnostics, we have other stuff as far as ride quality and row unit downforce. Like I said, there's just some other things that we can look, maybe more on our side to see, but maybe, you know, if we're on the phone with you, this might be where we want to go. So another thing kind of here to wrap up, talking about the hydraulic downforce is, you know, we know physics comes into play here. And so whether you have that planner or this planner, a lot of times we have, you know, closing wheels of some sort. We might have row cleaners, but say for instance on these closing wheels, having, you know, a little bit tougher time closing that seed trench, a little bit tougher conditions, and we increase our pressure, or whether we have the springs like that planner does, and we maybe go from that first notch to the second notch, or first to the third, or something like that. Just remember that this is a pivot point. So our row unit shank here, if we put more pressure down there, it's going to lift our shank out of the ground. And so it may not be much of an adjustment, but you might need to think about, once again, it kind of goes back to this ground contact, but you might want to think about increasing that downforce just a little bit to kind of help offset, to make sure, once again, we're getting that consistent seed depth, so we can get that consistent placement at that point. Same thing with row cleaners, whether you want to do a little bit more aggressive work with those row cleaners, or maybe they're all the way out. So once again, kind of a back to physics class, but just remember that when you're going out and doing that. So a lot of stuff that you can do before we hit the field. Obviously we know that when we come to planning time, you know, we're always wanting to go. So if there's some stuff that we can do beforehand as far as checking these systems out, making sure, doing that air purge test, valve test, making sure all that system's going to work, so we can do and have the best optimal performance. So